Hello everyone, for this lesson, let's talk about the integration of a function radix of 1 minus x cubic 1 dx. For this function, how could we solve it? So first of all, we could change the form of this function to change the denominator to negative the radix of 1x cubic minus 1 dx. And then we could put the negative to the front. So it will be equal the radix of x power 3 minus 1 dx. This form is not a regular form, so how could we use some ways to solve it? We could use the substitute first. Because we do not like the radix, we could use the substitute u equal the radix of x cubic minus 1 divided by x. Why I want to use this form? Since the du divided by dx it will be equal x squared. So the first item, the differentiation of the first item, the radix of x cubic minus 1 prime and times x minus the differentiation of the second term. So we keep the first item and times x prime. Then we could calculate it out. So for the first item, the differential of it will be 1/3 x cubic minus 1 negative 2 divided by 3 times 3 x squared. This is chain rule, and times x minus the first item we need to keep it there, so it will be the radix of x cubic minus 1 times 1, and the denominator is still x squared. We could continue to simplify the equation. It will be equal, the first item, it will be equal x cubic minus 1, 2 divided by 3, and the denominator will be x, and the second item will be the radix of x cubic minus 1 divided by x squared. So the dx will be equal x, we will change this one to the denominator. So x divided by x cubic minus 1, 2 divided by 3 minus the radix of x cubic minus 1 divided by x squared. and the denominator is 1 du. Then we could substitute the du by dx. The function will keep it the same. Cubic x. So times we will bring the dx into this function. X divided by x cubic minus 1, 3 divided by 2 divided by 3 minus the radix of x cubic minus 1 divided by x squared 1 du. So we can find that we could do some cancellation, or we could do some reduction since they are reducible. So it will be the first item. It will become x divided by x cubic minus 1, and the power will be 1 divided by 3. And the second item, it will become x cubic minus 1, 2 divided by 3 divided by x squared 1 du. So now you can see why we wanted to design the u equal this one. We could change it, we could continue to simplify this one and substitute the x by u. So it will become 1 divided by 1 divided by u minus u squared du. So now this equation just have u parameter. 1 divided by u minus u squared 1 du. We could continue to simplify it, and it will become u1 minus u cubic du. And for the 1 minus u cubic, we also can use the equation to expand it. It will become 1 minus u times 1 plus u squared, and the denominator is u and du. For this one, we could bring the negative into the denominator, so it will become u minus 1 times u squared plus u plus 1, and the denominator is same, u du. For here, we could use the fraction decomposition to change this one item to 2 items. It will equal u minus 1, and the second item, the denominator will be u squared plus u plus 1. And for the denominators, we could assume the first one is au plus b, and the second one is cu plus d. It will become if we put them together. So the first item au plus b will times u squared plus u plus 1, and the second item will be u minus 1 times cu plus d, and the denominator will be u minus 1 times u squared plus u plus 1. Here is a plus. Okay, and for the nominator part, we could expand it and then to compare it with the original one, and then we could calculate all the parameters a, b, c, d. So we could expand the nominator first. It will become au cubic plus au squared plus au plus bu squared plus bu plus b plus cu squared plus du minus cu plus d and it will equal u. So the a will be equal 0, since the right side there is no cubic item, and for the square item is similar. It will be a plus b plus c equal 0, and for the au, bu, and du and minus cu, the coefficient will be equal 1, since in the front of u is 1, and then in the end the b plus d, it will equal 0. Then we could solve these 4 equations for the second one and the fourth one. Since the a equals 0, so the second one we could change it to b plus c equals 0, and the third one we can change it to b plus d minus c equal 1, and the last one is still b plus d equals 0. And for these 3 equations, for the first one and the second one, we can compare it. We can get the c equal d. If c equal d, we bring it to the second equation. So we could get the b will be equal 1. Then we could solve all of them out. So we can get the coefficient a equal 0, b equal 1, and c equal d equal minus 1. I think I made a mistake here. It's minus d. Sorry about that. I will change them. It's cu minus d. So the last equation, it will be b minus d equals 0. B minus d equals 0. Yes. And then the c is not equal d, and the b is not equal 1. We could recalculate it. Sorry about this. For these 3 equations, so we could get the c equal negative d, and c equal negative d. So the second equation, it becomes b plus 2d equal 1. Since the b minus d equals 0, so from these 2 equations we could get the d equal 1 divided by 3. And the C will be equal negative 1 divided by 3. And the B equal D, so it also equal 1 divided by 3. And A equal 0. Continuing, we could bring the 4 parameters into the equation, so it will become negative 1/3 and 1 divided by u minus 1 du plus 1/3 and the integration of u squared plus u plus 1 and u minus 1 du. This form we are more familiar now, and for the first item it's very easy. It's just 1/3 log u minus 1. And the second part, we could keep it the same first. 1/3 integration u squared plus u plus 1 u minus 1 du. And we could separately to calculate the u minus 1 divided by u squared plus u plus 1 du. If we could calculate this out, so we solve this problem. It can be written to u plus 1 divided by 2 squared plus 3 divided by 4 u minus 1 du. And here we could continue to do the substitute. And use the m equal u plus 1 divided by 2. So the du will be equal dm. And the equation we can write it to m squared plus 3 divided by 4, and the denominator we could change it to m minus 3 divided by 2 and dm. We can write it we can simplify it. It will become 4m minus 6 and 4m squared plus 3. Numerator and the denominator will times 4 at the same time. We could change it to 2 items. The first one is 4m divided by 4m squared plus 3 dm minus 6 integration 6 divided by m squared plus 3 dm. And the first item, 4m divided by 4m squared plus 3 dm. This one is also easy. It's also a log function. So to do the integration, we can bring the 4 come out first. 4 times log 4m squared plus 3. And times, use the chain rule, so it will continue to times 1 divided by 8. Yeah, so we can continue to simplify it. Log 4m squared plus 3. That's for the first item. We also calculate it out. And the last item, the last one, it will be 6 divided by 4m squared plus 3 dm. For this one, we could use the substitute first. Since this one is very similar to the tangent function, we could use the m equal square root 3 divided by 2 k. So the equation will become dm equal square root 3 divided by 2 dk. So the equation will become 6 divided by 3k squared. K squared plus 3 times square root 3 divided by 2 dk. We could continue to simplify it, so it can be written as square root 3. Since the denominator 2 and 3 can be cancelled by the numerator 6. So the equation, it becomes k squared plus 1 dk. We are very familiar for this one, so this one is just the arctangent. The integration of this one, it will be square root 3 times arc tangent k. And we could bring the m value into the k, so it's arctangent 2 divided by square root 3 times m. So we solve this one, and we could bring the u value. We could change it, and there is another constant, so we need to plus c. And for the previous equation, and we could change the m to u. So the previous equation, it will become 1 divided by 2 log 4 u plus 1 divided by 2 square plus 3. And the second item is minus square root 3 times arc tangent 2 divided by square root 3 times u plus 1 divided by 2 and plus the constant value c. And we can simplify it. It will become 1 divided by 2 log. And for this one, it will become 4 u squared and u times 4 plus 4u and plus 1 plus 3 is still 4. Okay, and then minus square root 3 arc tangent 2 divided by square root 3 u plus 2 and 2 are cancelable, so it will be 1 divided by square root 3 plus 6. We can take a look. We solve this one, and finally we just need to bring the change the u value to the x, so we get the final answer. So the final result will equal negative 1 divided by 3 log u minus 1 plus 1 divided by 3 times 1 divided by 2 log 4u squared plus 4u plus 4 plus 1 divided by 3 times square root 3 arc tangent two divided by square root 3 u plus 1 divided by square root 3 plus c. And since the u value equal the radix of x cubic minus 1 divided by x. So we just need to bring the u value into the equation, then we get the final answer. So the result will be 1 divided by 3 log parentheses the radix of x cubic minus 1 divided by x minus 1 divided by x minus 1 and plus 1 divided by 6 log and parentheses x cubic minus 1 square divided by 3 and x square, and the coefficient is 4, plus the radix 4 times the radix of x cubic minus 1 divided by x and plus 4. The third item will be 1 divided by square root 3 times arc tangent 2 divided by square root 3 times the radix of x cubic minus 1 divided by x plus 1 divided by square root 3, and the last item is c. So here is the final result. If you have any question about this video, leave me a comment. If this video helps you, please like my video and subscribe it. Thanks a lot for your watching.